Okay, so let me continue today exploring these functions from a plane to a plane, so that hopefully by the end of today's lecture I will come down to the computations you actually have to perform for the current homework. But before going into those details of computations, let me try to continue drawing this picture of different points of view on those functions. So I still look at the functions from a plane to a plane, and I'm still trying to compare three different points of view: geometric, physics, and algebraic. And let me start with geometry. Well, do geometers consider this kind of functions? Well, sure, yes they do, because those represent geometric transformations of objects, of shapes. So they do consider that, and let's see how far you can get with this, with the current geometric knowledge, and what that knowledge suggests you to do. So basically what we learned is that there are basic examples, right? So the basic examples of those transformations. So we keep thinking about transformations of the plane. And there are two basic examples that I look at. Those were translation and rotation. Now, those are very easy to understand. So you take a plane and either translate so that the whole thing moves by the same vector, or you rotate so that one point stays the same, the rest is rotated by a certain angle. Let's fix that angle, alpha radians, and think about that transformation, not the process, but just transformation. So what is going to be the next step geometrically? If you want to understand better all possible functions, or at least a decent amount of them, what should we study further? What should we look at next? Should we go further by examples? Do you know more examples of interesting geometric transformations? Do you have any strategy to bring those examples? And do you have any way to classify that some examples are easier and some other examples are more difficult? Well, not really. Right? Geometrically, we are kind of stuck here. Well, of course, anybody can suggest some transformation, right? Take a plane, do something, and here it is. But, well, do we have any consistent way of looking at those things, at those transformations? Well, not really. Now, what we may want to do is we may want to explore a different point of view on the same objects. For example, physics suggests to look at fluid flow, for example, right, and understand a function from a plane to a plane as a function from a point to a vector. Right? Every point gets a velocity vector assigned. And then, from that point of view, we also see some examples of easy, simple flows. One example is this kind of translation flow, when everything is flowing in the same direction with the same speed all the time. And that is going to be, I'll call it constant flow. And the reason I'm writing it on the side is that the relation between geometric transformations and physics, that relation provided by algebraic formula, right, suggests that translation does not correspond to constant flow if we use this interpretation through algebra, and constant flow does not correspond to any of these two. It is really something new. Now, what was the flow corresponding to translation, well, it was something new. We didn't even see in physics yet, because we looked at constant flow and we looked at circulation. Those were the two flows that were sort of easy to understand, and neither of those did correspond to these two geometric transformations. So translation corresponded to something like explosion, when everything was flying from one point away, right? And the further you go, the faster points fly away. And rotation corresponded to, well, something not even easy to understand. Well, on the other hand, physics suggests, well, these two are easy to understand physically, so why don't we try to understand them geometrically? Because if something is easy to understand, well, it should be easy for both physicists and geometry. Now, is it easy for geometry? So what was the geometric transformation corresponding to the constant flow? Constant flow is about assigning the same vector to each point. Geometrically, it means assigning the same point to each point. So the whole plane collapses to one point. That's the transformation. Apparently not a very interesting one. Right? All the shapes become just one point. No, it doesn't matter what shape it was, it just becomes one point. Circulation becomes something that's not easy to understand. Right? So there was some transformation, but not clearly related to either rotation or translation or collapse. It was definitely not a collapse. Now, that's the picture that you get when you explore a different point of view. Well, the benefit of that is that you clearly get some insight into what can possibly be studied and what can possibly be studied even further, right? You bring some phenomena that other people consider simple, and you didn't. So, well, it makes sense to study those. Okay, well, are you still gaining a bigger picture of whether this transformation is of the same level of difficulty as the ones you had before, or it is more complicated? Well, not really. Right? So there is still no consistent picture of what goes on and how to continue. On physics point of view, well, we see those constant flow, circulation. Geometry suggests explosion, something new, something we did not expect at the beginning. How do we continue? Well, yes, we see one potential step to continue, something geometers consider simple. Physicists should probably study and understand better. But is there a consistent point of view and a way to continue? How should we continue studying those physics flows? What would be the next thing to do? And how difficult are these four in comparison to each other and in comparison to everything else? Right? Physics does not suggest any physics does not suggest any measure of difficulty and any way to continue.